Hello, welcome to our first lesson. Today we are going to begin our lesson with sets. What do we mean by sets? When we talk about sets, we are looking at what? Group of objects, group of what? Distinct objects. So by definition, a set is an ordered collection of distinct objects. So the objects that are in the group are not in any particular order. Okay, and the objects in that set, we refer to these objects as elements or members of the set. So we can say that the set of all vowels in the English alphabet. So this is a set. It has a distinct property, which are vowels of the English alphabet. So that is what we mean by a set. So we can also say this can also be a set, the collection of all even numbers. Less than 10. So this also a set. These are groups of objects that have distinct property. Alright, let's look at this group of objects and see which of them form a set. A group of intelligent students. Wow, the first group with the property intelligent students doesn't form a set because intelligent is relative or is subjective. Everyone will have his own definition of intelligent. A student that one person sees as intelligent will be different from what another person considers as an intelligent student. So this doesn't form a set. The next one, a group of students scoring more than 95% marks in your school. This is a set because in my school I can find students that score more than 95 mark. So this forms a set. The third one, okay, a group of the most talented singers in Ghana. Again, just like the first one, most talented is also relative. So this doesn't form a set. It doesn't form a set. Okay. The next one, group of pretty girls. Also, just like the first and third, pretty. What looks pretty to you might be different from another person's. So this doesn't form a set. Now, a group of odd natural numbers less than 5. This absolutely forms a set. Odd natural numbers less than 25 forms a set. Each element, I can find each element in this set. Then what about the next one? Group of girls of SHS 2 in your school. This one too is a set. Yes, because in my school I can find girls that are in SHS. So this forms a set. And then the last one, a collection of the most dangerous animals in the world. Again, this will be hard to define. This one too is also relative. The animal I see as dangerous might not be dangerous to you, so this doesn't form a set. Alright, now in collecting objects, there are two ways I can represent them as a set. One way is to list the elements of the set. So I can list the elements of even numbers less than 10. So this way of writing or describing these sets is what we call the roster or listing method. So in representing or describing a set using the roster or listing method, the elements of the set are listed in curly braces separated with commas. So that's one way of representing. Another way with which I can represent or I can describe a set is by using a set builder notation. So I can decide to describe my set using a set builder notation or the rule method. So with the set builder notation method, I can describe a set using the properties of the set. So if I take a set like B, I can describe it as X is such that X is a property so that defines which x's are included. So this is a set builder notation. With a set builder notation, I describe the properties of x that are included in the set. So with this same example of even numbers less than 10 in the set builder notation form, so x is such that x is an element of even number less than 10. So these are the two ways that sets are described using the roster method or the listing method or the set builder notation method. Now let's write the set builder notation for these sets. Alright, so for the set of whole numbers less than 8, x is such that x is a whole number where x is less than 8, greater than or equal to 0. Then we close our braces. So this is the set builder notation for the set of whole numbers less than 8. So for the second problem, the set of positive even numbers less than 15. So even numbers in algebra is denoted by what? 2x. So 2x is such that x is a natural number. It's a natural number where our x is less than or equal to 7, greater than or equal to 1. Okay, so any value of x will give us any value of x between 1 and 7 will give us an even number that is less than 15. So let's look at 1. So 1 times 2 will give us 2, which is within the range, and it is less than 15. So if x is 2, 2 times 2 will give us 4, which is less than 15. If x is, let's say, like 5, 5 times 2 is 10, which is less than 15. Or the maximum number x can be is 7, and then 7 times 2 is 14, which is less than 15. So this is how we write the set below notation, or we use the set below notation to describe sets. Now, the final problem. Write the set of all natural numbers x such that 2x plus 3 less or equal to 13. So 2x plus 3 less or equal to 13. So we have to write a set of all natural numbers. We are listing it. So with this, I have to solve for y. What value of y? What value would y take? That will be less than 13. So in solving for y, in isolating y, I solve this inequality question. So it will be 2x plus 3 minus 3 less or equal to 13 minus 3. So this will give me 0, so I'll get 2x less or equal to 13 minus 3 is 10. So if I divide through by 2, I'll get my x to be less than or equal to 5. So to write all natural numbers for x that are less than, that will make this part of the equation less than 13. It means all elements that are less than natural numbers. So let me use E to denote it. So it will be 1, 2, 3, 4, including 5. So this will make the left hand side of this inequality question less or equal to what? 13. So let's pick the highest one, which is 5. 5 times 2 is 10 plus 3 is 13, which is less or equal to 13, so it's true. And if you pick the minimum 1 times 2 plus 3 will give me 5, which is less or equal to 13. So these are the natural numbers that will make this statement true. Alright, let's look at subsets. When we talk about subsets, we're looking at two sets where all the elements in one set is found in the other set. Then that forms a subset. For example, when set A has the elements 2, 4, 6, and then we have set B with the elements 1, 2, 3, 4, 5, 6, 7, up to 10. So you can see that set A's elements 2, 4, 6 can be found in set B 2, 4, 6, all in set B. In this case, A becomes a subset of B. So when all elements of one set is in the other set, then it forms a subset. So A is a subset of what? Set B. Now, I want you to note these two important things about subsets. Now, there are two important things about subsets. An empty set is a subset of every set. That's one. And then two, the set itself is a subset. So the set itself is a subset. So these two important things. So an empty set is a subset of every set, and the set itself is also a subset of itself. Alright, so let's consider set A. So we set A, the elements are 2, 4, 6. So we mention the subsets, or write down the subsets. The subsets will be first the empty sets, then we have the elements. 2 is a subset, 4 is a subset, 6 is a subset, 2, 4 is a subset, 2, 6 is a subset, and then 4, 6 is also a subset, and finally the set itself, 2, 4, and then 6 is a subset. So we have the two important things or properties of subsets here, empty sets and the set itself. So in all, how many number of subsets does set A produce? 1, 2, 3, 4, 5, 6, 7, 8. So the number of subsets of set A is equal to 8, which we call the power set of A. So when you talk about power sets, it refers to the collection of all subsets of a set. That's what we mean by what power set. So when I say the power set of set A, all subsets of set A. So the power set of set B means all the subsets of set B. Alright, so power sets talks about the collection of all the subsets of a set. So the number of subsets that a set produces, the total number of subsets a set produces, is what we refer to as the power sets. Now, in the earlier example, say of set A, it is easy for us to list all the elements of set A with the cardinal of 3. So the total number of elements in set A is 3. Right. So to determine the power set of a given set, we look at the cardinality of the set and raise 2 to the power of it. This is what I mean. The set that we just looked at, set A, which has the elements 2, 4, 6. So the cardinality of this set is 3. Cardinality of set A is equal to 3. So to find the power set of this set, I take 2, then I raise to the power of the cardinal of the set, which is 3. So 2 power 3 will give me what? 8. So whenever I'm giving a set, or I'm considering a set, the power set of a set, I will look at the cardinal of the set, that is the number of elements in the set. Then I raise 2 to the power of that cardinal. Then that will give me the power set. That's the total number of subsets that the set will produce. So if I have, let's say, our set B, which has the elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. Sorry, and 10. So if I have set B with these elements, so the cardinal of set B is what? Is 10. There are 10 elements here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. So the power set of B will be equal to what? 2 to the power 10. And then 2 to the power 10 is equal to, let me bring the calculator. Okay, so 2 power 10 will give me 1024. So there are 1024 subsets in a set of 10 elements, in a set containing 10 elements. Okay. Alright. So in a case where not all the elements in one of the sets is not in the other set, then it's not a subset. For example, if I take, let's say A, then I have the elements 2, 4, 6, 8, 10, 12. And then I have set B, which has the element 1, 2, 3, 4, 5. So in this case, A is not, it's written with this notation, subset of B, because we can't find 12 in set B. All these elements are in set B. All 2, 4, 6, 8, 10. They are all here, except for the 12. So in this case, A is not a subset of B. Alright, so that is it about subsets. So when we take two sets and one set has all its elements in the other set, then that forms a subset. And then we looked at what? The power set. So we talk about the power set, the number of what? The total number of subsets in a given set. And then when we look at subsets, an empty set is a subset of every set. And then the set itself is a subset. And then to find the power set, the number of subsets in a given set, we take 2 and raise it to the power of what? The cardinal of the set. That's the total number of elements in the set, and that will give us the power set of that set. So that brings us to the end of this lesson. In the next lesson, we'll look at Venn diagrams and the relationship between 2 and 3 sets.